Question 1, Part E. Using the substitution x equals 2 times sine theta, or otherwise, calculate the integral of x squared over the square root of 4 minus x squared dx from x equals -1 to x equals the square root of 3. We'll start with the substitution x equals 2 times sine theta. Now there's two things we need to do. Firstly, we need to square both sides of this equation. So we get x squared is equal to 4 times sine squared theta. That's because later on we'll need to replace the x squareds in the integrand with 4 times sine squared theta. The other thing we need to do is to differentiate x with respect to theta. So dx d theta is equal to 2 times cos theta. Multiplying both sides of the equation by the differential d theta to isolate the differential dx, we get dx is equal to 2 times cos theta d theta. Next, we need to change the limits of integration from being in terms of x to being in terms of theta. Now, going back to the original substitution, we need to express theta in terms of x. So rearranging this equation, we get theta is equal to inverse sine of x over 2. So we divide both sides of the equation by 2, we get x over 2. Then taking the inverse sine of both sides, that's how we get theta is equal to inverse sine of x over 2. Now when x is equal to -1, theta is equal to inverse sine of -1 over 2, and that gives us a value of theta of -pi over 6. And when x is equal to the square root of 3, theta is equal to inverse sine of square root of 3 over 2, and we get theta is equal to pi over 3. We can now proceed to express the integral from being in terms of x to being in terms of theta. Now we can replace the x squareds with 4 sine squared theta. That's the substitution here. And the differential dx is replaced with 2 cos theta d theta. We also replace the limits of integration as well with these new limits that we just found. So the integral becomes 4 sine squared theta times 2 cos theta d theta over the square root of 4 minus 4 times sine squared theta, from theta equals -pi over 6 to theta equals pi over 3. Let's consider the denominator, in particular 4 minus 4 times sine squared theta. Now using a Pythagorean trigonometric identity, noting that cos squared theta plus sine squared theta is equal to 1, we can express what's inside the surd in terms of cos squared theta. So 4 minus 4 times sine squared theta is 4 cos squared theta. So the integrand is 4 sine squared theta times 2 cos theta d theta over the square root of 4 cos squared theta. Now we have a term that's a square, and we're taking the square root of a term that's a square. So taking the square root of a square, the square root of 4 cos squared theta is 2 cos theta. And that will cancel with the 2 cos theta in the numerator here. Also, we can take this constant multiplier, the 4, outside of the integral as well. So what we're left with is sine squared theta d theta inside the integral, and the entire integral is being multiplied by 4, and of course the limits stay the same. Now we need to integrate sine squared theta with respect to theta. Now recall that cos 2 theta, so this is a double angle identity, is equal to 1 minus 2 sine squared theta. We can rearrange this identity to make sine squared theta the subject, and we get sine squared theta is equal to half times open bracket 1 minus cos 2 theta close bracket. So expressing the integrand in terms of the cosine of a double angle, the integral becomes 4 times the integral of half times open bracket 1 minus cos 2 theta close bracket d theta from theta equals -pi over 6 to theta equals pi over 3. Now the 4 times half simplifies to 2, and performing the integration, the integral of 1 with respect to theta is theta, and the integral of negative cos 2 theta is -half times sine 2 theta. applying the limits of integration, we get 2 times, now open square bracket, and open round bracket, we get pi over 3 minus half times sine 2 pi over 3 close round bracket minus open round bracket. We're going to use the lower limit now. Negative pi over 6 minus half times sine of negative pi over 3 close round bracket, close square bracket. We need to deal with these exact ratios here and here as well. Now, sine of 2 pi over 3 is root 3 over 2, and sine of negative pi over 3 is negative root 3 over 2. So we get 2 times, open square bracket, pi over 3 minus half times root 3 over 2 plus pi over 6. Now the plus comes from this double negative here. Plus half times negative root 3 over 2 close square bracket. And that simplifies to 2 times open square bracket, pi over 2 minus root 3 over 2, close square bracket, and that equals pi minus root 3.